Right, so you should have your note sheet out and ready. Calculators, very helpful for this. All right, so you've investigated properties and relationships of sides and angles in similar triangles. In this section, you will examine a special characteristic of right triangles. Given the figure with right triangle MAE, AN is perpendicular to ME, and the measure of angle M is 70. They want you to determine what these angles are. All right, so the first thing we need to look at is what exactly do we have here? We actually have three triangles. We have, providing this lets me write, this larger one. We have this smaller one right here. And we have kind of this medium-sized one right here. Okay, so we have a total of three triangles in this guy. The one thing they're telling me right now is that the measure of angle M is 70 degrees. So right here is 70. And because AN is perpendicular to ME, we also know that this is a right angle, so that's 90. So they want us to find the measure of M to A to N. So this little itty bitty piece right here. What's that going to be? Look at just the blue triangle. We need a total of 180 degrees still. What's that little part going to be? Good. 20 degrees. Okay. So that takes care of MAN, 20 degrees. Okay. So now they want A or EAN. So E to A to N. Oh, I'm sorry, N right here. Okay. So this part right here. Now we know that total angle MAE is 90. So that means that part in the green is supposed to be what? Say it loud, say it proud. 70 degrees. Okay. And then what do we have left for angle E right here? 20. That's it. So do you guys see how like these guys kind of share a lot of different angles? So they're all similar to one another. Questions on that? All right, let's take a look at number 2. So it says justify that triangle MAN is similar to ANE. Now here's what I'm going to do. I'm going to draw these three triangles out. That's actually going to help me with number 5 here in a few minutes, okay? This just has the space for it. So this is my little guy. I'm going to put M, here's A, here's N, and we know that this is 70, this is 20. My medium-sized guy, oops, sorry. This is why Mrs. Smith is a math teacher and not an artist. All right, so here's my medium-sized triangle. That's A, that's N, that's E. Again, here's 70, here's 20. And then we have the main larger one, right? Which is M, A, E, which is 70 and 20 there. So now the question is, if they're talking about MAN, so the small guy, and ANE, which is this guy, how are these two similar? Like, what's the criteria? What would be the criteria? Tony? Oh, the angle measure the same. So what do we call that? I'm sorry? They're definitely similar, but how? What'd you say? Angle. So this is angle. What am I missing? Squiggles. We need squiggles. Very good. I like that word, squiggly. I don't like the word moist, though. Yeah, the more you know, moist. Ooh. Say damp instead. Nope. All right, questions on this? All right, so the large triangle is also similar to the two smaller triangles. So complete the similarity statement, naming the large triangle appropriately. All right, so in this case, we have MAN, which means if I'm going to state that it's similar to this one, I have to go with the same angle measure. So MAN, AEN. So I'm going to put triangle AEN. And I'm going to have that this is similar to, sorry, that looks like an R. It's actually an M. To M to E to A. So just like with triangle congruence, and when we were proving triangle similar, naming the triangles is still very important. So you got to make sure those angle measures match up. Okay? All right, number 4. Name the type of special segment AN is in relation to MAE. So I'm just going to go back up to the original here, and I'm going to highlight. This is what we're talking about, AN, in comparison to the entire triangle, the bigger one. Okay? What's that guy called? You can find the orthocenter using it. Just went over topic 5 yesterday, and it's all wiped from our brains now, huh? Ooh. Who remembers? It's an altitude. Very good. All right, so this happy fellow is an AN, is an altitude. All right. Now, I'm looking at number 5 right here, but I'm going to go up to those 3 triangles we used, okay? But I'm just going to read this this one real quick first. So it says, given AN equals 9 inches, NE equals 12 inches, use the Pythagorean theorem and the properties of similar triangles to determine these segment lengths. Show your work. All right, so in this case, let's take a look at AE. So AE is right here. So this is what we're trying to find. And this is the information we were given. We were given this is 9, this is 12, and we are given this is 9 as well. Everybody with me? So how can we find AE, or X in this case? What am I going to use here? It's named after an old dead Greek guy. Did a lot of things in mathematics. Pythagorean theorem. So let's take a peek at that. So we are given 2 legs, right? We're given a leg of 9 and a leg of 12. And that equals x squared. So this is 81 plus 144 equals x squared. So I've got 225 equals x squared, and then I take the square root of each side. So what does AE equal? $15. Nice job. There we go. Does that make sense where that's coming from? Questions before I move on to MA? How many of you are like, so far, pretty easy? Okay, how many of you are like, maybe? How many of you are like, this is just not happening today? Okay, so not happening. Okay, we're doing okay. We're doing good. Glad to see that no one had their thumb all the way down. All right, let's take a look at MA. So MA is right here. So I'm just going to label that Y. Okay. Now, I don't have MN. But I do have quite a bit of information that will help me here. I have that this is, I'm going to write that in. This is 15, which will help me. And I also have 9, that this is 9, this is 12, that's 12. So I have enough information to set up a proportional relationship. Okay, so that's going to look like Y over 15 equals 9 over 12. Does everybody see that? So again, we're just getting in. These are similar triangles. We said they were, so we're going to apply that proportional relationship. So this is going to be Y over 15 equals 9 over 12. Why don't you guys solve for it, round to the 100th, and tell me what it is. Anu? 11.25. Very good. Questions on this? All right, MN. That's the next one they want us to find. I'm going to label that with a Z. So I have MN over AN, and I have AN over EN. Now, I want to give you guys kind of a pro tip here. Could I have used this and this? Absolutely. But if I accidentally calculated wrong, that means everything that travels with that is going to be incorrect as well. Okay? So at all times, if it is at all possible, use what they give you, not what you've calculated. Okay? I'm not saying you can't use it. I'm just saying be careful while using it. If they give you enough information, use that information they give you. Okay? So in this case, it's going to be Z over 9 equals 9 over 12. Why don't you guys tell me what does Z equal? Again, round to the 100th. What'd you get? Perfect, 6.75. All right, questions on that? So you guys kind of see how what we've learned so far is kind of coming back together, all in one? All right, let's flip to the other side. Are there any questions before we move on, though? Okay, so it says, when the altitude is drawn to a hypotenuse of a right triangle, then the length of the altitude is the geometric mean. Between the segments of the altitude. When the altitude is drawn to a hypotenuse of a right triangle, then each leg is the geometric mean. Between the hypotenuse and the part of the hypotenuse that is adjacent to the leg. All right, so the geometric mean is a positive number x such that a over x equals x over b. Now the other thing you guys are getting a lot of words here, but probably a visual would be helpful, right? So I'm going to draw the visual up here with geometric mean, at least to the best of my ability. Just remember, Mrs. Smith is not an artist. So your geometric means is going to be this side, or that altitude. Okay? I'm going to highlight them. So this, that. Okay? Does that make sense? So those are what you're kind of using. Those are the geometric means for something like this. And I forgot. I need a right triangle right there. All right, questions so far before we move on. Does that help a little bit? Okay. Again, we're going to be hitting this a little bit more tomorrow. So just stick with me. That's the only thing I can really recommend, okay? All right, so let's get into, now today is just kind of the basics of this, guys. So let's take a look at, this is our last example, so we're good, okay? It says, find the geometric mean between each set of numbers below and write answers in simplified radical form. What does that mean? Shane?
Like the answer for like the number outside of this
Yeah, which means no decimals. Ouch. All right. So be careful. You guys, I would lie to you if I said, oh, we're only gonna see it for this. There's so many more radicals coming up. Sorry. I know, Emma. I'm sorry. Emma's got this very disgusted look on her face, and that's okay. I understand. So, is what it is. Let's get comfy, but let's talk about letter A. So, in this case, I'm looking at this. Remember, we have A and B. I'm just going to call this my A, this my B. It honestly doesn't matter because all we have to do is make sure that they're multiplying together. Okay? So, this is going to be 4 over x equals x over 9. And then we apply that proportional relationship. So this is going to be x times x equals 4 times 9, which is x squared equals 36. I take the square root of each side. I'm getting x equals plus or minus 6, but can I use the negative 6 here? No, because it says positive. So in this case, it's just x equals 6. Now, I'm going to put you guys to the test, and I'm going to give you a hint. B and the you try it are radical form. I want you guys to set it up as far as you can go. All right, so try the geometric mean first. You can always go back and simplify the radicals later. All right, but give these two a shot. Let's see what we remember. I think didn't we already review radicals in here? I can't remember. Maybe a little bit. Show of hands. You're still working on these two. If you are, it's fine. I just want to know. Okay. Let's check. Who's got the answer for letter B? Go ahead. Yeah. Perfect. 3 square root 3. Anybody need to see this? Anybody? It only takes one. All right. How about the you try 6 and 8? Who's got that one? Go ahead. 4 radical 3. Oop, let's make that look like a 4, shall we? Mm-hmm. Who needs to see this one? Anybody? Now, let's be honest with ourselves. Who's struggling with radicals right now? Just tell me honestly. It's totally fine. This is a safe space. Okay. A couple people. That's okay. All right. If you are struggling, please come see me. I will help you with how we got these answers. Now, everybody else, if you guys look at the bottom, this is why Mrs. Smith made a mistake. All right. The bottom is your homework. The bottom of the second page. That's your homework for today. 3, well, maybe a little more than 3. Number 2, I'm going to tell you right now, you know how I split up those triangles? You're going to have to do that same process. And I am not going to help you with splitting up those triangles. You have to be able to see it. I want you guys to give it a solid attempt. Okay? If we need to go over it, I'm fine with that. But I want you guys to give it a solid attempt on your own first. Does that make sense? Okay. So if you guys look at, was it like example 5 where we had those 3 triangles, but they're in 2? That's what you need to do. Okay? Questions? All right. That's it. Those of you watching at home, have a great day.